Hello, everybody. Welcome back. I believe we are streaming with any luck. And with any luck, you are looking at the. Hey, that's awesome, Bob. Well, I'm glad to hear that. I'm really glad that you're enjoying it. Um, so, we're going to do something a little bit different today. This is going to be what I'm calling Brief and Fly. And we're going to take a look at the ILS Localizer runway 33 to Fulton County Airport in Oswego County Airport in Fulton, New York. And why on earth did that just happen? So, hey guys, what's going on? So this is actually kind of an interesting approach for a couple reasons. First of all, because it's got some interesting elements to it in terms of use of DME to identify fixes. So there's a couple important waypoints on the approach and with the missed approach that you can identify using either GPS or, hey, Michael, what's going on? How are you? That you can identify using either GPS or VOR DME. And so I think it's kind of cool that you can identify some of these waypoints in different ways, and it's instructive for us. It'll be helpful for us to look at. But the other cool thing about this approach is I actually flew the localizer version of this approach on my instrument check ride, and it was kind of funny. It was the first of the approaches that I flew on my check ride, and I nailed it. But anyway, we'll talk out. I maybe have a little bit of information about that for you as we go along, because it was an interesting approach. It was a nasty day when I took my check ride. It was a really nasty day, and it made the approach interesting to say the least. And so I'll give you an idea of where this is. So this is an approach that I'm very familiar with. So this is the approach overlaid over the world map here in New York State. Let me zoom out here a little bit, give you a better idea of where we are. So this is central New York State, and this is where the airport is. This is where the approach is. This right here is my home airport, Kilo Romeo Mike Echo. That is Griffiths Airfield in Rome, New York. It's a former B-52 bomber base. And you can see it's got a 12,000 foot long runway, which is pretty unusual for a county airport. I mean, that's essentially what it is Oneida County Airport. And so this, the airport that we're looking at for this approach, it's about a 30-minute flight in the 152 or the 180 over to what we locally call it Fuzzy, because it's FZY, so everybody around here calls it Fuzzy. And then just south of here is Syracuse, and there's Syracuse International Airport is right down there. And you'll see when we fly it later, there's this huge lake right here, Oneida Lake, which we use as a reference to for flying around in this area. But but like I said, it's a neat approach. And let's talk about why it's a neat approach. So first of all, this is an ILS or localizer approach, so you can fly it either way. And for my check ride, I flew the localizer portion of the approach, and I'll go through both of them. And we've done a pretty thorough class on briefing approaches, but we'll go through the whole thing here just so everybody is familiar with exactly what it entails, and then we can do we'll actually fly the approach once we're done chatting about it. Now, like I said, there's some really interesting things about this approach, and it's a good one to look at. It even has circle to land minimums, which is pretty cool too. So to fly either the localizer or the ILS, you would tune in the 110.9 in your, let me bring this up a little bit bigger. You tune in the 110.9 in your nav radio, and in the older nav radios like we have in the 152 that we're going to fly today, you would have to check the Morse code identifier and make sure you've got the localizer tuned correctly. Final approach course is 330. It's to runway 33. And glide slope intercept is Hurdy, which is right here. It's at 2,400 feet. And it's about 6 miles from the 6 miles from the ILS transmitter. And we'll look at that a little more closely here. And that's 1,929 feet above ground level, and or above. It's actually height above airport, to be more specific. And so, if you think of about when you're flying an instrument approach, if you're trying to fly, or any approach for that matter, if you're trying to fly a 3-degree glide slope, what you're looking for is about 300 feet per nautical mile of distance on descent will give you roughly a 3-degree glide slope. And so you can see this is 1,929 feet. And then down here, Hurdy is 5.9 miles, so it's about 6 miles. And it's actually about 5 miles from the threshold of the runway. So about 5 miles, and you can see that the glide slope is a little bit steeper than normal. It's 3.55. So almost 2,000 feet in 5 nautical miles. It is a steeper descent than a normal, quote unquote, a normal descent. And we'll talk a little bit more about that in a second. There's an interesting note on this particular chart. You can see up here it says category A, B, and C. And if you come down here to the minimums, it is NA for category D aircraft, and those are aircraft that are flying 141 knots or faster on final approach, and you just can't get down from 2,400 feet to the runway at a reasonable descent rate if you're going that speed, which is why category D aircraft are not allowed to fly this approach. And hey, Peter, what's going on? Good to see you. So that's the first kind of interesting thing about this approach. The second thing that's rather interesting is the ILS decision altitude. That's 814 feet, and this is 343 feet above airport elevation. And the reason, so you would normally expect an ILS to be around 200 feet for minimums. And the same reason, it's a little higher for the same reason that we just talked about, because of the steeper glide slope on the ILS. So they don't want you getting any lower, because you're going to be descending at a steeper glide slope, a steeper angle. So that makes it that's the reason why we have higher minimums on this approach. Airport elevation is about 500. I would round this up to 500 feet if I'm thinking about it, if I'm flying it. And it's pretty flat ground out here in Western New York, and you can see the minimum safe altitude is based on the Syracuse VOR, which is a big part of this approach, and I'll show you the role the Syracuse VOR plays here in a little bit. But again, if you're west of the Syracuse VOR, you can come down to about 3,100 feet before you have to start worrying, and east of the Utica VOR about 3,700 feet. So that's the minimum safe altitude. The missed approach is climb straight ahead to 1,200 feet, climbing right turn to 3,000 on a heading of 100 outbound on the Syracuse VOR, radial 018 degrees. And remember, radials radiate out. So if the VOR is right here, the 360 degree radial is up. So radials radiate out, so the 180 degree radial would be down. And to fly a radial outbound from a VOR, you would need a from flag and a centered needle. Basically you would have your OBS tuned to the direction that you're flying. So in other words, if you wanted to fly the 018 degree radial out of the Syracuse VOR, you would have your OBS set to 018, and you would have a from flag, and you'd be flying a heading of 018 or a course of 018. And here we get to the kind of the first interesting bit about this approach. To the pager waypoint, which is a GPS waypoint, but you can also identify that by the DME off the Syracuse VOR at 15.9 DME from the Syracuse VOR on that radial 018. So we'll look at that down here in a second. Let's see. It's in the U.S., so transition level and transition altitude are both 18,000 feet, flight level 180. Nothing unusual there. And here we get to DME required. And the reason DME is required is because you need it to be able to identify the several of the fixes that we're going to talk about. So circling to runway 24 is not authorized at night. Now, why would they do that? That's an interesting question. I'm going to try and figure out. So this is an interesting little airport because there's several runways. There are intersecting runways. Let me get rid of this. So this is runway 24. Why would they not want you circling to 24? Maybe because they think the lights might mess you up. So whenever you're looking at a chart like this, the yellow is what lighting, right? City lights. And circling to runway 24 at night, I don't see any. Let's look at the VFR charts. I don't see any obstacles. Maybe this up here they're worried about? Ah, this is probably why. This stack right here. That stack right there and this hill right here at 739 feet. That's probably why they don't want you circling to runway 24 at night. Cool. So I always look to see like why do they have certain notes on the on a chart? Like what's the reason for it? Runway 33 helicopter visit. Okay, whatever. That's helicopter stuff. We don't have to worry about that. Pilot controlled lighting is 123.0. So this is a non-towered field. So if you come in here at night, you have to turn the lights on yourself. And I've told this story before, but the way I was taught to do it. So what you do is you tune that frequency, pilot controlled lighting 123.0, which is also the Unicom and the CTAF. What's the difference between CTAF and Unicom? If on a CTAF you're broadcasting in the blind, it's what we call broadcasting in the blind. You don't expect a response from anybody. You're just giving a position report where you are. Like if I'm 15 miles to the south of the airport coming in for this approach, I would make a radio call, Oswego County traffic, Cherokee 56125, 15 miles south of the field, inbound ILS 33. That just tells everybody where I am, what I'm intending to do. Unicom is a monitored frequency that it's not a tower, but it might be like the FBO. It may be whoever it is on the field might be listening to that Unicom. And like, for example, if you want to call, and they have cheap gas at this airport. So if you want to go, if you're coming in here for gas, you might call Oswego County Unicom, Cessna 4753 X-ray, 10 miles to the west. Inbound 33 is the fuel truck available, and you would wait and hopefully hear back from somebody. But to get pilot controlled lighting at night, you tune in that frequency, and there are three intensity settings for the lights. There's low, medium, and high. I don't remember if that's exactly how they call them, but so if you click your mic button 3 times, you'll get low intensity lights. If you click it 5 times, you'll get it medium. If you click 7 times, you'll get high. The one thing that my instructor, my first instructor taught me was, and he used bad language when he taught me this. He said, click the crap out of it. He said, don't sit there counting how many clicks you're doing. He said, just start clicking the damn thing and get the lights on. So that's how you get pilot controlled lighting. So looking here at the plan view of the approach. So this is, now we get into some of the interesting stuff. So first things first, Syracuse VOR plays a pretty big role in this approach, and it's sort of cut off down here at the bottom of the page, but you can see here it says Syracuse VOR IAF. That's the initial approach fix for the approach. Now, what is an initial approach fix? This is one of the few times where the FAA has been very very straightforward in how they've named something. The definition of an initial approach fix is an approach, a fix from which the approach begins. Makes sense, right? So the initial approach fix is where the approach starts. Now you don't have to start an approach at the initial approach fix. You could get vectored to final, in which case you would probably get vectored outside of HRDY, which is the glide slope intercept. And the reason you can tell that, or the way you can tell that, is because of this Maltese cross right here. We call it a Maltese cross. And that is where you intercept the glide slope for the ILS. And so you could get vectored to OSCO, for example. You could get vectored anywhere between OSCO and HRDY and cleared for the approach. But the kind of the way to fly the full approach, or sort of, I don't know if I would call it the official way, but the way to fly the full approach is to fly to the Syracuse VOR. And this is a little bit tough to see. You would fly to the Syracuse VOR, then outbound on a heading of 017 or on a course of 017, excuse me, from the Syracuse VOR, 2.6 miles. You're getting ad spam by YouTube's. I'm sorry to hear that. I don't think I can control that. I will check that setting and I'll see if I can adjust that. My apologies for that. Let me see. Let me see if I can change that. I think Peter said something about that at one point as well. My apologies for that. I will see what I can do for the next class that you don't have to deal with that. But so you would fly to the Syracuse VOR. You would then turn on a course of 017 for 2.6 miles. And then this is where you would find OSCO intersection. And that is where you turn in. If I just move this a little bit, sorry for zooming around all over the place. But this is the OSCO is where you would turn final for the no, that's okay. It's I'm sorry to hear that. I'll see what I can do about that. So you would turn at OSCO inbound 330 on the final approach course, okay? So basically there are two ways to identify OSCO intersection, and this is where we start getting into the interesting part of this approach. So OSCO intersection, or OSCO waypoint, is a waypoint. It's a GPS waypoint. If you you could find this waypoint in your GPS unit, your GTN 650 750, your G1000, your GNS 430 530. You could just enter OSCO intersection and you'd be able to find it using GPS. And the other way you can identify OSCO intersection is 2.6 nautical miles on the 017 degree radial from the Syracuse VOR. So that's one of the interesting points about this approach, is there are multiple ways to identify OSCO waypoint. And that's a very FAA knowledge test type question. How many ways are there to identify a certain waypoint? But that's also why the note for DME required up here is there, because this is an ILS or localizer approach. Can you use GPS? Yes, you can, and I'll explain how much GPS you can use, but GPS is not required to fly the approach. DME is, because that's the only way to identify these waypoints without GPS. So the third way to identify OSCO waypoint is, you can see this is KFZY. This is the localizer transmitter from the airport. You tune in the 110.9 dial. You actually don't have to dial in the 330 because it only. So a difference between a localizer transmitter and a VOR transmitter. A VOR transmitter, the O in VOR stands for omnidirectional. It broadcasts a radio signal in 360 degrees. The the localizer on the ILS only broadcasts one radio or one frequency because that's the only one you need. You need 330. That's what you have to identify in order to fly the approach. So you actually don't have to dial your OBS to 330. No matter what you had your OBS set to, the only thing it's going to indicate is whether you are left, right, or on the 330 degree course here inbound to the localizer transmitter. So the other way to identify OSCO would be 110.9 330 distance on your DME of 12.7. Now, what is DME for those of you who don't know? DME is distance measuring equipment, and I'll show you once we get into the airplane. It simply gives you a distance in nautical miles to whatever the transmitter is. Some VORs do transmit distance information. Those are VOR DMEs. It's not a VORTAC, it's a VOR DME. Some VORs do not transmit any distance information. That's simply a VOR. A VORTAC is the TAC part is TACAN, which is a military navigation system, which obviously is not used for civilians or used by civilians. So those are the three ways you can identify OSCO. You can identify it using your GPS. You can identify it 2.6 DME off the 01.7 radial from the Syracuse VOR, or you can identify it at 12.7 DME on the 330 degree inbound heading or inbound course to the localizer. Now, which radial would this be? It would be the 150 degree radial because it's the 180 degree reverse of 330. And these are the kinds of things that I enjoy. Anyway, so there's three ways to identify that. Now, I mentioned you don't have to use GPS, but you can. Now, how much GPS can you use on this approach? You can use GPS on this approach. No, you know what? I mentioned that at the beginning. I didn't mention it just now, but you're absolutely correct. You would have to identify technically, and that's what these dots are. Dot 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 dot. That's IFZY. That's what those are right there. You can see this. That's the Morse code identifier right there at the bottom. So you are correct. You have to identify that if you're using an older nav radio. If you're using something like a GTN 650 or 750 or a G1000, those verify the frequency automatically for you. So how much GPS can you use on an ILS approach or a localizer approach for that matter? You can use GPS up to the final approach fix, which in this case is Hertie at where the Maltese cross is at 2,400 feet, D5.9 IFZY. You can use GPS to identify the Syracuse VOR. You can use GPS to find OSCO. You can then turn inbound using GPS to Hertie. Once you get to Hertie, you then are required to switch to either the localizer or the ILS, depending on which one you're flying. So you can use GPS for this stuff, and in a lot of ways, it's easier. The only thing you have to remember is if you're using something like a GTN 750 or a G1000, you have to remember to switch the CDI needle from magenta to green, to fly the final approach segment from Hertie on in. And a lot of people, it's just one more thing to remember. People forget it. And I'm sure people have failed check rides for forgetting it. So now let's talk the missed approach real quick. So the missed approach And again, this missed approach is on the chart 3 times. The written version is up here. The overhead, the plan view gives you these dotted black lines show you what the missed approach is. That's the second time, and it gives you the headings. It doesn't give you the altitudes on here, but it does give you the headings to fly. And then it's down here again in this section. And the reason why it's on the chart 3 times is because it's very, very important. You have to be able to, you have to know what your missed approach is going to be before you get to the missed approach point and realize you have to go missed. And one of my favorite sayings in aviation is a landing is what happens when you don't find any reason to go around. And the same thing is true for approaches, for instrument approaches. Never, ever, ever assume that you're going to make it in and not going to have to fly the mist. Oh, you've got to be ready to fly the mist. So the way we're going to fly the mist, so you come down, let's say you're flying the ILS portion of the approach, you come down to the decision altitude and you have to make a decision. Do I have the runway in sight or do I not have the runway in sight? And if you don't, then you would climb to 1,200 feet straight ahead. And then once you hit 1,200 feet, you make a climbing right turn to 3,000 onto a heading of 100. And you can see they put these inserts in the plan view of the chart when things aren't close enough together to be able to fit them on, a normally scaled overhead. So you would fly the 100 degree heading this way, and you see it comes out over here. It continues over here, and we talked before about the difference between a heading and a course. So a heading is what is on your heading indicator. That's why they call it a heading indicator. And so you would literally just fly 100 on your heading, regardless of what the wind is doing. So if you wanted to fly a 100 degree course, you would have, that's a course over the ground, a track over the ground. You would have to adjust for the wind, and we'll be adjusting for the wind when we fly this later. And I'll show you what I'm talking about. But in this case, you don't have to be precise. You just have to be on that 100 degree heading. And what we're doing is you come out this way, and then the Syracuse VOR is down here, and you've got to switch again from that 110.9 to the 117.0 of the Syracuse VOR, and then you tune your OBS to a 018 degree course with a from flag, because you're flying a radial. Radials are from flags. So you'll fly a 100 degree heading until the needle centers, and you turn and intercept outbound on a heading of 018 until you reach the DME 15.9 mark, and that's where pager intersection is. Again, you can identify pager. It's not an intersection; it's a waypoint. You can identify the pager waypoint using GPS as well. However, you cannot, if you're flying this missed approach, you cannot just climb straight ahead to 1,200 feet and then enter direct pager and fly straight to pager. You can't do that. You've got to fly the 100. You have to fly it as charted. You fly the 100 degree heading, intercept this outbound radial from the Syracuse VOR, and then this is one of my favorite things in the world. And what I would do in this particular case, there's 2 ways to fly this hold. The way that they would tell you to fly it, technically, first of all, there's no legal requirement to fly a hold in any particular way. There are direct entries, teardropped entries, and parallel entries. You can enter the hold any way you want to. You don't even have to use one of those 3. You can make up an entry if you want to. The only thing that's required is that you get established inbound on the hold on the inbound 198 course. You can do it however you want. The way they would teach you to do this technically is to fly outbound, stay on that 018 degree course outbound for 1 minute. That's the reciprocal of the 198 degree inbound heading. So you'd be flying out this way. And then they would have you, it's called a parallel entry. So you're paralleling the inbound course outbound. Let's see if I can make this a little bigger. So you'd be paralleling the inbound course going in this direction. And then you make a left turn. And it's like a 240 degree turn that gets you turned around this way. And then you intercept the 198 degree heading back in, or course back into Pager. The reason I don't like this, there's two reasons I don't like a parallel approach. Number one, you can see this, what we call a racetrack symbol right here, or symbol, yeah, is good enough. This is protected airspace. If you are at or above 3,000, which is the holding altitude, if you're at 3,000 feet and you are in this airspace, you're not going to hit anything. I'm a big fan of not hitting anything in airplanes. So a parallel entry, you are a little bit on the outside of the protected airspace. Do you have a little bit of protection over on this side? Yes, a little bit. However, I much prefer to be inside the protected airspace at all times. And the other thing I don't like about parallel entries is you're going the opposite. So this is a right-hand turn, right? These are right-hand turns in this hold. You're going against the hold. You're going against the direction of the hold. And your first turn in the hold is against the direction of the turn. So you're making a left-hand turn in a right-hand holding pattern. I mean, with GPS and like moving map technology, like in a G1000, GTN 750, that type of thing, it's not too bad. You can you have a visual picture of what you're doing, or if you have an iPad with a moving map, it's not too bad. If you're doing it the old-fashioned way, just with a paper chart, and you're doing this, you start making a turn in the opposite direction of the turns of the hold, you can get confused. I mean, I don't like that. So what I would do is fly a teardrop entry. And for whatever reason, most instrument pilots don't like teardrop entries. And teardrop entries are the easiest possible way to enter a holding pattern. And the way you fly a teardrop entry is, so right-hand turns are standard turns in a hold. These right-hand turns, that's a standard holding pattern. In a standard holding pattern, to fly a teardrop entry, and they call it a teardrop because it goes like this, and there's like a teardrop in the upper part of the hold. You fly the outbound heading minus 30 degrees. So let's call this 020, right? So you would cross Pager, turn left to a heading of 020. I mean, it's 018, but what's the difference? 020. Sorry, correction. 020 minus 30, which is 350. So you would cross this, turn left to outbound minus 30. So 020 minus 30 is 350. Fly a 350 degree heading for 1 minute, and then make a standard rate right-hand turn and intercept the inbound 198 degree heading. And then you're in the holding pattern. Then you just fly your racetrack. And when you do that, you're in protected airspace the entire time, number one. Number two, like I said, you're flying, technically it would be a heading of 348, but you can do it 350. You don't have to be specific because you're flying into protected airspace. So you don't have to really worry. As long as your altitude is good, 350 is close enough to 348 for the outbound. Just a super easy way. And all you have to do is be able to add and subtract. So that's how I always fly holds if I have to. And I actually had a fun time. I flew this hold earlier today quite a few times, trying to get the wind correction. And I'll show you that once we get into the plane. The wind correction part of a hold is fun. We'll do a class on holds at some point. I'll talk a little bit about this right now, I guess. So since we're on holds, so the way you fly a holding pattern is, if nothing else is indicated, this would be a 1 minute hold, a 60-second hold. What you're trying to do is when you intercept the 198-degree heading, or course rather, into pager, when that needle centers, you start a clock. And you want 60 seconds from when that needle centers until your DME indicates 15.9. That tells you you're at pager. And then you make your right-hand turn, standard rate, 17 degrees per second. Or no, 3 degrees per second, excuse me. 17 degrees per second would be pretty fast turn. 3 degrees per second, outbound to the 018 degree heading outbound. If your inbound leg, let's say, turns out to be 70 seconds, it's too long, then what that means is you've flown too far on your outbound heading. You need to shorten your outbound heading. So instead of flying a 60-second outbound heading, you would fly a 50-second outbound heading. And then once you come back in and intercept your inbound heading to pager, you would again time it and see if you get 60 seconds. You adjust the time on the outbound section, on the outbound leg, so that your inbound leg is 60 seconds. That's the trick to flying holds. And you also have to be, you would also correct, depending on where the wind is coming from. The wind up at this part of the world is almost always from about 300, 330, which means it's going to be coming left to right as we're looking at this. So you would actually be flying kind of a heading pointed out this way a little bit, maybe a 010. So we'll see that later as we get into flying the hold. Let me see. Did I miss any questions? Hey, Brew Pilot, what's going on? I'm very glad, man. I'm glad you're enjoying them. Kenny, what's going on? How are you? So I think I probably spent enough time on that. This is the kind of stuff that I really enjoy. Now there is an alternate hold. Now, where is the alternate hold? So for this one, you would fly the 100 degree heading until, I mean, there's a different way to identify pager intersection, and that is from, so here is the Syracuse VOR, which we're using to identify that waypoint, and then the Watertown VOR, if this eventually loads, the Watertown VOR is up here, and you could identify it using that as well. But that's neither here nor there. We'll leave this. We'll leave that for right now. Do you always fly outbound 60 seconds for the first time? Yes. You fly outbound 60 seconds the first time, and then you would see, okay, I just flew the outbound you start your timing once you have settled on the 018 degree heading. Once you level your wings at 018 degrees, then you start your timer, 60 seconds, and then you do your turn back in around to 198, and then you time that inbound leg to see, okay, how, it may be 55 seconds, it may be 80 seconds, depends on what the wind is. And then the next time you fly the outbound leg, then you adjust the time on the outbound leg to see if you can get that inbound leg to 60 seconds. You'll never get it perfect, but it's fun to try. I did like 5 or 6 turns in the hold trying to get it exact a little bit earlier today. But yes, that's how you would do it. Hey, Edie, thank you so much. Appreciate that. So I'll show you when we fly it, which we should get to relatively soon. I can talk about charts all day, which you probably noticed by now. So the side view of the approach, let me do this. Sorry for like moving this all over the place. So the side view of the approach just gives you a horizontal view of the steps that you come down on the localizer. Now, so for the ILS, you would come to OSCO, you would come inbound 330, come down to 2,400 feet and level off at 2,400 feet, waiting for Hertie. Um, you don't have to intercept exactly at Hertie. If you can intercept further out. And I'll show you once we're flying it. If you see the needles and you want to, like you would actually stay at 3,000 feet until you intercept the glide slope and then just start down. But technically speaking, you should come down to 2,400 feet, level off, and then wait for the needles to center and then come down on the glide slope. Um, I would prefer to intercept further out and fly a 3-degree glide slope, or a 3.55 in this particular case, from out here, rather than coming down, leveling off, and then starting a descent again. But that's just my preference. And so these, you can see there. So there's Osco, Hertie, and Uyiwu. And the only thing that Uyiwu is for the localizer approach. But anytime you've got any sort of these indications on the chart, you should use them to your advantage. So one of the things you should do is make sure that, so you're going to have a local altimeter setting, right? You're going to get the local altimeter setting from the AWOS in this particular case, ASOS, and that's the Automatic Surface Observation System. And I won't go into those right now, ASOS, AWOS, but we'll go into them at some point. So that's where you get your weather, but your weather could be 50 minutes old. Not with an ASOS. I'm sorry. Actually, that's not correct. So you would get your weather, you would set your altimeter. Theoretically, when you cross Hertie at 2,400 feet, or theoretically, when you cross Hertie, you should be at 2,400 feet when the glide slope needle intercepts. It might not be. So Hertie is actually not is not legally or technically the final approach fix. The final approach fix is 2,400 feet with your glide slope needle centered. That's what your final approach fix is. What's the difference? The difference is it could be if your altimeter is slightly off, if you forget to set your altimeter. So if they give you a distance, which they do, D5.9, they give you an altitude, 2,400 feet, you should make sure that at D5.9, your altimeter, even if the needle is centered, you should make sure your altimeter says 2,400 feet, because that's indicated here in the chart. And let's say you forget to set your altimeter, and it shows when you intercept, it might show 2,300 feet, and you think, oh boy, or let's say it shows 2,500 feet, and you say, oh, I'm high, and you go down a little bit lower, you might sort of put yourself in a position where you're lower than you think you are. So these are just ways to kind of check yourself on an approach. Make sure you're where you are and where you think you are. When I cross, even if I'm on the ILS, when I cross a Uyiwu at D2.4, I would make sure, am I at 980 feet indicated? Even though this is actually only for the localizer part of the approach. Now, how do I know this is only for the localizer part of the approach? Because it's this dotted line right here. So flying the ILS, you fly inbound 330, you come down to 814 feet. Do I have the runway? If I don't have the runway, I'm going missed. When you're flying the localizer part of the approach, now somebody asked last time, why would you only fly the localizer part of the approach? There's two reasons I can think of. Number one, if you have an older airplane and you don't have an ILS receiver, you only have a localizer receiver, you don't have the glide slope, you only have a localizer receiver, then you can only get left-right guidance. So therefore, you can only fly the localizer approach. The other thing that can happen is sometimes the one or the other part of the ILS transmitter will go down. It has happened, and it has killed people where they're flying an ILS, and the glide slope portion of the ILS transmitter goes down for whatever reason, stops transmitting, you either get an incorrect glide slope or you don't get any glide slope at all. And in that particular case, you would have to fly the localizer. And I'll tell you a good little trick for flying ILSs here in a second too, because there's a way. Good pilots always have backups for backups for backups. So, in the age of GPS and the moving maps and G1000s and all this stuff, there's a lot of the art of flying approaches like this that kind of are getting lost, which is really unfortunate. And this actually, you can't time this approach, so I can't use it on this one. So I'll have to give you that example sometime on an approach when you can use timing. But one of the great tricks for an ILS approach, if it's an ILS or localizer like this one is, and if there is a timing section down here that tells you how much time it takes from the final approach fix to the missed approach point, that's for the localizer approach. Even if you're flying the ILS, start your timer at the final approach fix, and if the glide slope dies for whatever reason or goes out for whatever reason between, or maybe your radio has something go wrong between Hurdy and 840 feet, which is the localizer minimum, you can then just switch to your timing and fly the localizer approach instead of having to go missed and then come back around and fly the localizer approach, if that makes any sense. Frame gen questions, I'll deal with it at some other time. Peter, the speed you're flying during holding. So for this, oh, that's a great question, by the way. For this holding pattern, because there are no Class D or Category D aircraft, you really can't fly it with a particularly fast airplane. There is a maximum airspeed. I believe it's 230 knots in the hold. And that's basically in any hold up to, I think, 10,000 feet. And then above that, I think it's 260 knots. I will let me look that up, and so I can tell you for sure. Pattern airspeeds. So, holding pattern airspeeds. Standard, okay, so up to 6,000 feet. So this holding pattern is 3,000 feet. So you right turn to 3,000 and out here. So you're at 3,000 feet. The maximum airspeed up to 6,000 feet is 200 knots indicated airspeed. And I was a little bit off on this one. So, and then for 6,000 feet up to 14,000 feet, your max holding airspeed is 230 knots indicated. And above 14,000 feet, it's 265 knots indicated. So it does depend on your altitude, but for most GA airplanes, you can't fly 200 knots anyway. And most airplanes, period, you're not going to be flying that airspeed in a hold off an approach. Let me see. That's a great question, Peter. So that's the ILS portion, and then you would fly that down to 814 feet. And again, you can see the glide slope. You see here GS 3.55 degrees. And we talked earlier, so 5.9 minus 0.9 is 5. I'm not that good at math, but I'm that good. So, and this is, like we said, Hurdy is 1,929 feet above the airport. So that's what, 1,929 feet in 5 miles. And I said earlier, it's about 300 feet per nautical mile. So it should be about 1,500 feet in order to fly a normal glide slope. Because this is shorter, and I don't know why it's shorter. That's an interesting question. But you have to fly a steeper angle. So it's 3.55 degrees. You would come down to 814 feet. And, sorry. I will definitely do something about the ads for the next one. I apologize, guys. So you would fly down to 814 feet indicated. And then if you don't have the runway environment in sight, you go miss. Now, what is the runway environment? Runway environment in this particular case, So these are the lights that we have on the approach, and they're always in the same place in the chart. And by the way, Navigraph charts are the best charts you can have for flight sim. It's great that Microsoft put the Lido charts, and it's Lido, not Lido. It's great that Microsoft put the Lido charts in the sim. Lido charts are confusing, and they're basically only for commercial operations. So if you're flying GA aircraft, you're not going to find a lot of... Jeppesen covers about 26,000 airports in the world. Lido covers about 8,000 airports in the world. So, but anyway, you're always going to see your lights right here, the approach lights right here. And in this case, it's the REILs, which are the runway end identifier lights, and those are two blinking white lights at the threshold of the runway. And then there's a PAPI, which is the precision approach path indicator. Those are the four lights on the in this case on the left hand side. The two white, two red is what you're looking for on the left hand side. So what you would need to be able to see at 814 feet, if you can see the runway and identifier lights, you can keep descending. If you see the PAPI, you can keep descending. If you see like runway centerline lights, runway edge lights, if you see any of the like if it's daytime and you can see any of the paint, the markings on the runway, you can descend down to 100 feet above the ground looking for the runway. If not, you go missed. The localizer portion of this approach, you cross Hurdy again at 2,400 feet, and then you do what the old timers, which I'm rapidly getting there, they call it dive and drive, and you really would have to dive on this one because it's like we said, it's a shorter distance. So you would have to go from 2,400 feet down to 980 feet and level off until you get to Uyiwu, and then you can come down to the localizer minimums of 840, and you can fly 840 until you reach the runway threshold, which is D 0.9 off the localizer distance. That's the missed approach point. So the missed approach, this black space bar down here is the runway, but that's not the threshold of the runway. Is not the missed approach point. The missed approach point is D 0.9. So that's why you need DME, because you need DME to determine where the missed approach point is. And we talked last time, this V right here, and we're so on the localizer, you're 369 feet above the airport, above airport elevation. When you reach this D 1.7, this V right here is called the visual descent point. And what the visual descent point means, if you have the runway environment in sight by the visual descent point, you will be able to make a normal descent and landing on the runway without having, to use an excessive descent rate or any sort of maneuvering. And that's at the D 1.7 distance. Once you get past D 1.7, like D 1.5, 0.4, 0.3, once you see the runway, if you do, you are going to have to descend at a steeper rate to get down to land. So that once you get past this V, if you do see the runway, you're going to have to maneuver a little bit more aggressively to be able to land. And then we just have the rest of the information down here. So ground speed in knots at your 355 degree descent rate, or glide slope rather. I always figure about 80 knots in the Cherokee, and so I would be right about 500 feet a minute, because it's between 70 and 90. I would just kind of even that out and call it 500. It's actually about exactly what it would be. And then these speeds are, or these descent rates are for faster speeds. So if you're coming in at 100 knots, you would have to be at a descent rate of 628 feet per minute to maintain that 3.55 degree glide slope and to keep your needle centered. Now, mind you, these are ground speeds. They are not air speeds. They're not indicated air speeds. So how if you don't have a way of knowing your ground speed, I mean, you're presumably landing into the wind, so you can generally assume that your indicated airspeed, take a few knots off of it, that's going to be about what your ground speed is, depending on what the winds are. Circle to land. So circle to land is kind of interesting. Like I said, you can see there are two runways at this airport. There's the runway 1533, which is the one we're landing on. There's also runway 246. So you could circle to land. Like, let's say the winds are pretty strong from 240. You could fly this ILS to 33. And then what you would do is, let's say you're coming in at 90 knots and you get to 1,000 feet and you can see the airport. You can level off at 1,000 feet. You could level off as far down as 920 feet, but let's say you level off at 1,000 feet, and then you can fly. Let me see if I can get the. Is there a ground chart? There is not. Oh, there we are. Let's see if it makes sense looking at it on this. But you would come down to 920. Okay, so you're flying the ILS approach to runway 33, and if the wind is coming strong in this direction and you want to land at runway 24, fly the ILS to 33. Let's say you break out at 1,000 feet and you can see the airport. You maintain 1,000 feet and you just circle around in this direction and then land on 24. One of the things to know about circle to land approaches, let's say you come down to 1,000 feet, you break out of the clouds and you can see the airport. If you are circling to land on runway 24, and as you're flying over here to make a base turn for runway 24, if you go back into the clouds, you have to go missed. You can't wait to see if you come back out of the clouds again. If you're on a circling approach and you go into the cloud and you go back into the clouds, you have to go missed. So missed approach, as we talked about earlier. All good stuff. I'm going to start up Microsoft Flight Simulator here, and let's go fly this approach. And I was flying this approach earlier, and one of the interesting things, and I think a lot of people would be surprised at this. I don't know how many people. So I'm going to fly this in the mighty Cessna 152. I don't know how many people actually hand fly approaches in the sim. I do not use autopilots for GA aircraft in the sim. I do for the Carinado F-33, which I absolutely love. Great airplane. Let me just make sure this is. There's an update for the sim? You're kidding me. Really? There's an update for the sim? I just got an indication that there was an update. Wonder what that's about. Okay, cool. We got it. So anyway, I don't fly. I don't use autopilots on GA airplanes in the sim, just because I want to test myself to be able to hold altitude, hold the heading, navigate, change radio frequencies, set my OBS. I want to be able to do all that stuff and kind of keep my feeble mind, operating in understanding what's going on. So what we'll do is what I did earlier. We'll take off here out of fuzzy. And I'm not going to do the engine start and all that stuff. I'm just gonna start on the runway. I'll start on runway 33. We'll take off, and I get to write on the thing. Let me see. Where is that? There is a way to write on here, which would be kind of fun, but not going to work. Okay, so what I would do is, or what I'm going to do, I'm going to fly out this way. We'll fly down here, and then we'll come like basically on a easterly heading to intercept the VOR. We'll come north here to Osco, and then we'll start the descent. And I'll talk you through, like I was saying earlier, you can cross Osco and come down to 2,400 feet and level off and then intercept at Hurdy. What I actually prefer to do is cross Osco, and if the glide slope needle is above me, and I think it's going to be, I would prefer just to stay level at 3,000. And then once the glide slope needle comes in, then I would start my descent, and I'll cross Hurdy in the descent at 2,400 feet. I just prefer it. I don't want to have to come down, level off, and then start descending again. Fulton ILS Localizer-3 approach. Would I be able to fly from the Syracuse VOR using the lower VOR receiver? Yes, you absolutely can. The only reason I'm not going to do that is because I only have one ILS one indicator in my airplane. But yes, Michael, you absolutely would be able to do that, and that's the huge advantage of having two having two nav radios and having two VOR indicators or ILS indicators in your airplane, is because you can essentially, you would be able to tune in 110.9 and 330 here in your number one radio, and then tune in 117.0 and 017 here. And when those needles cross, when they both center, then you know this is where you are. So it's actually a great way of doing it. And that's a great question, by the way. It's a real, and there are some waypoints that the only way to identify them is using dual VORs, using two. Well, you can do it with one, but you'd have to be pretty quick. So what I'm going to do it with one. So I'll have the Syracuse VOR 117.0 in the backup frequency. I'll have the 110.9 in the number one, and then I'll just punch it and flip them. So we're going to be doing, like I said, we're going to be doing this in the mighty Cessna 150. It's taking my sim forever to load because we are, there's some sort of an update. I don't know what that was all about, but, the reason, so the whole idea behind, you might say, okay, well, why don't we do this in like a TBM, or a Bonanza or something? To me, doing it in glass cockpit sort of defeats it. It just makes it almost too easy. And doing it in the 150 or the 152, we're able to go slow enough that you can follow along, and that's the whole reason for an airplane like that, the Cessna 152, is because it makes it easy to makes it easier to do things because it's slow. That's why trainers exist. So there is, let's go to fuzzy. And I am using the WB-Sim JP Logistics 152 in Flight Sim 24, which is a great airplane. I'm going to do live weather. And if we go into the clouds, we go into the clouds. If we don't, we don't. I'm literally, I don't know. How far away am I? Probably 50, 60 miles to the east of here right now. So let's do this. I think we probably will go into the clouds, which would be great. But I want live weather because live weather makes it easier to or makes it more interesting. I don't know what makes it easier. It certainly makes it more interesting. So let me start my head tracker here. And yeah, the WB Sim. I tell you what, I haven't flown this plane in the reason I got this plane out, so to speak, and got it set up for this stream was because I wanted to use a steam gauge airplane with a DME, and there aren't any in the sim. There's I think I know the Just Flight Warrior has it. The Just Flight Arrow has it. The not Coronado. The Black Square. I think Black Square Bonanza has a but they're too fast for what I want to use them for. And why are we not departing here, ladies and gentlemen? So can we depart? Yeah, I think we're gonna get some clouds. This is gonna be great if we get going here. So the there used to be a good little restaurant in this airport as well, but the WB Sim airplane is fantastic. I have a 150 in real life. This is a 152. It's infinitely more powerful. It has 10 more horsepower than the 150, but it's just a fun airplane to fly. The Cessna 150, 152 is a fun airplane to fly. It's just I just enjoy it. I don't enjoy sitting here staring at the screen waiting for it to start, but that's kind of what makes trainers entertaining airplanes. And I watched a woman fly. Yeah, I knew he was going to do this, so it's got me on runway 6. I don't know why. Oh, good. So we're gonna have. Oh, we got real weather. Look at this. I guess it's gonna rain at my house here pretty soon. I don't know why we're on runway 6, but we are.
State restored.
All right, let's set our altimeter here. All right, let's set all that. There's 117.0 and 109. That's perfect. All right, so make sure my doors are closed here. All right, I'm gonna keep the windows, or the windows. I'm gonna keep the yokes hidden so you guys can see everything that's going on. Just so you know, the DME distance that we're talking about is gonna come up right here, right where it says. This is the DME indicator, nautical miles. This is what it's gonna show us, and this feature is kind of cool. It's going to show us our airspeed in knots going towards or away from the VOR. So that's secondary information. That's pretty cool. Ooh, we're gonna fly a real approach. All right, so we're gonna see right here, nautical miles, the DME that we're looking for, and we're also gonna bring up our Navigraph charts, and hopefully my mug is not gonna cover the chart here. Actually, I think I'm gonna make this smaller. We'll see. But basically, like when I'm flying, when I was flying this earlier, I just had I was just keeping my eye right here in this lower corner to be able to see the VOR, to be able to see the DME distance. All right, we'll have the Navigraph charts join us here in a second. So, let's see. Alright, no flaps, mixture is rich, carb heat's cold, we're good to go. Hopefully the Navigraph charts will join us here shortly. There's a pitch. Alright, so I'm gonna make a... Okay, that was because the charts are coming in. So I'm gonna make a left turn here. Alright. Basic attitude flying. So what I'm trying to do is keep that dot right there on about the 10 degree mark, nose up. And there's 1,000 feet. Feeling a little bit better about that. Where is my chart? Okay. Now what I want to do is come around to a southerly heading so we can go find that Syracuse VOR. So 117.0. Can you please? I want to come up to 3,000 feet. I'll go heading at 210 for right now, up to 3,000. Come on. Charts usually don't take this long. I don't know what's going on. So 2,300 climbing 3,000. There we go. That's what we're looking for right there. No, I pressed the wrong button. Alright. So, what I want in the chart when I'm flying. So now I'm comfortable come southbound. Because I don't want to be too close over here to the... I don't want to be too close to... There's 3,000. Bring the power back here. Level off. Adjust my power. Well, southerly heading. 2,400 RPM. Alright. So. I just didn't want to be too close to... Too tight into the VOR. So, what we shall do... We've got 117... which is the Syracuse VOR. So once we get down here a little bit further, I'll center this needle with a 2 flag, and what that's going to do is bring us straight to the VOR. And once we hit the VOR, then I'll go outbound 107 for 2.6 miles and then intercept the ILS. So looking pretty stable here. Hopefully you can see the instruments well enough. Did I balance the fuel earlier? I don't know if I did. Alright. Oh yeah, fuel is on or off. There you go. So what we're gonna do, let's see, let's brief this. 1099, we've got that. 330 is final approach course. Glide slope intercept 30 at 2400. Decision altitude is 814. I'm certainly not going to call it at 814. I would call it probably at 850. Airport elevation, I'm going to call it 500 feet. Let's see. Missed approach. Climb straight ahead 1200, climbing right turn to 3000 on a heading of 100. That's all I need to know for right now. So... I'm gonna keep coming south here. So this is the area in which I live. It is a beautiful area, and there's a ton of rain up in this part of the world because of there's a big lake right up over here. But so right now, just trying to maintain 180, 3,000 feet. And again, you can just barely see the DME distance right over here. I may move my view over so you can see it a little bit better. But you can see how I mean, like, if I was doing this in like a G1000 airplane, all you've got to do is just follow the overhead. It's pretty darn easy. It's almost cheating. So legally speaking, on an IFR flight, you have plus or minus 300 feet from your assigned altitude. So I was just down at 2,800 feet. So I'm still legal, but it's not. You shouldn't be 200 feet below your assigned altitude. You should be at your assigned altitude. I'm just gonna keep going south here for a little bit, just to make sure that we can, because I don't want to have too acute a turn right here to come northbound there. And this airplane is very stable, which is what we like. Be even more stable if I wasn't flying, but I am. Alright. Just a little bit more here. And you'll be surprised how far out we are. So we'll be turning about an 11-mile final. And in this airplane, 11 miles takes a while. The wind earlier was out of about 300. So, And what we'll do is, if we hit the missed approach point and I don't have the runway environment in sight, we will go missed. And I may just go missed anyway. So now I've got a do I have this? No. Let me see. Let me go like this. So now we've got a 2 flag, right? We've got that 117 dialed in. So now what I'm going to do, well, it's going to be, what about 090? So I'm going to go the other way. And wherever that needle centers, about 125. So if I turn right or turn left, we're heading on 125, then I will be heading straight for the Syracuse VOR. Now I've obviously flown through that course as I was talking about it, but the other thing you want to think about in instrument flight is making standard rate turns, and the way you do that, your little turn coordinator down here. And I just went through the 125 just so we can get that needle back to the center. These white bars right here on the bottom, if you have your wingtip on that little white bar, that is a standard rate turn. So let's go to the Syracuse VOR at 125 degrees. And now let's see if we get pushed in one direction or the other. Let's see if that needle moves. I'm right on the 125. Let's see if that needle moves one way or the other. If it moves one way or the other, we're going to know where the wind is coming from. So that's why. So you can see the needle is moving over to the right. That means the wind is coming from the right. We're getting pushed to the left. So I'm going to correct back here to about let's say about 135. We're also getting in close to the VOR. And we're climbing. So once we get, come on, stop climbing. When you get over terrain like that, you'll climb. When you get over like houses and buildings and stuff, you'll climb because of the heat. So once we get to about 3 miles here, I'll tune it to 017. And then I'll wait to catch that from flag. And then we will do that. Let's see here. All right. So now I'm gonna put it to 017. So that's this heading course right there, 017. About right there. And you can see I've got, I'm gonna do it right like this. And you can see I've got 017 set right here, and I've got a from flag. So when this needle centers, I'm going to turn to a heading of 017, and that's what we're looking for out of life. And that's, we've got 1.8 miles here to go. And I'm just going to hold, I got way right. I want to be on a heading of about 125. But this is kind of the fun thing about doing this in, and there's the airport right in front of it. Is that the airport right in front of us? No, it can't be. That's Syracuse. That's Syracuse. But this is the fun part about doing this hand flying, because you have to keep track of all this stuff all by your lonesome. That needle's gonna start moving here pretty quick. Why is the needle not moving? Yeah, so it just flipped on me like instantly. So 017, and that needle will, the needle's gonna flip back to 2, right, or to from rather, right there. So I'm gonna go I'm gonna go ahead and go about 010 because the needle is to the left of where we are. So we'll go about 010. And it's at what, 2.6, and we're already at 1.1, so we're about 1.5 miles. And so what I'm going to do now, I'm going to switch to that 110.9. And see, now that's the glide slope needle is above us, and the localizer needle is to our right. So I'm going to make a turn here to a heading of 330 to intercept this localizer needle. And that's going to put us on that 330 final approach course. You just kind of have to guess, depending on how quickly it's coming in and how much you have to turn. They try to make turns for approaches like this. They try to make the turn like 30 degrees or less. They don't want you making big turns. And we're at 3,000. We've crossed. Well, we will cross Osco here in a second. But you can see the glide slope needle is above me. I could come down to 2,400 once we get to 12.7, right? But what I want to do, I'm going to stay right here at 3,000 feet and just wait for this needle to come down. And then I've got my needle centered and I don't have to worry about descending, leveling off, descending again. So I'm at about 320, which is my wind correction, and that's bringing the localizer needle back in. So I'll come back to about 325. See if that keeps it centered. So I have a feeling the wind is usually between 300 and 330, somewhere in there. So I'm just gonna hold this right now and just wait until. See, Hurdy's at 5.9. So I got another 6 miles to go. And you can see the airport. It's right in front of us, right there. Like I told you, you'll be surprised how far out you are. So, and see, I'm getting pushed again. So that wind is a little bit out of the north. So I'm gonna come back to 320 and see if I can hold that. And what you try to do with a wind correction, once you figure out what heading is gonna prevent you from getting from the needle getting pushed, then whatever that heading is becomes your new 330, right? So you want to fly a 330 degree course, but the heading, the heading over the ground is what you want to fly in order to keep the 33 course to the airport or to the runway. So if it turns out that 320 keeps that needle centered, then instead of 330, you just keep an eye on 320 and fly 320 in. If that makes sense. You call it a reference heading. And so instead of flying 330, I'm flying 325. Because that's correcting for the wind. And see, now the glide slope needle is coming in. Now remember, Hurdy is at 5.9. We're at 8.9. But like I said, I'd rather intercept further out than cross at 3,000, drop down to 24, and then cross again. So what I'm going to do, I'm going to get ready to, in a faster airplane, I would add flaps at this point. I would add flaps when I intercept, but not in this one. This one's too slow. We'll be here for the rest of the day. So that needle's moving over to the right again. So now I want to get back to 330 and see what that does for us here. And when you're about a half a dot above, then you can pull some power and just start coming down. And I know about 500 feet a minute is what I'm going to need. At least that's a decent guess. Let's get back to 320. See, that wind changed on me. For a little bit, I was getting pushed left. Now I'm back to getting pushed right. I'm just going to let it settle here for a second. And at 5.9, I want to be at 2,400 feet. Alright, the glide slope is centered. Localizer is moving a little bit, so we want to get a little bit further over. Maybe 320. And once we hit 5.9 right here, we want to be at 2,400 feet. There's 5.9. We're just above it. So the altimeter is off by a little bit. Okay, but now I want to come. I'm going to add some carb heat because this is a Cessna. Bring some power out. And I'm going to go first notch of flaps. And now we'll get ourselves into the white arc. And I'm just going to stay in the white arc for right now. See, the wind changed again. Right about 1,000 feet above the ground, the wind always changes. So you can't establish like the 320 and just hold it for the entire approach in. It's gonna change, and you have to be ready to change with it. There's 325. Nah, we're not gonna come down that much there, Charlie. All right. I'm still liking 325 as a reference heading. Not liking getting low, so we're gonna just pitch the nose up just a tiny bit. A little bit of power. 325. And what we'll do, we'll get down. See, even doing these visually, I mean, I'm not really paying attention to the runway, but even doing these visually is challenging to keep the needles centered. So 814, 325. I want to trust that correction. See, right about 1,000 feet, that wind changed. Now let's try 330 and we'll see what we get. But I mean, my needles have been pretty consistent all the way down. I'm just keeping an eye on the vertical speed indicator, keeping an eye on the attitude indicator, and keeping an eye on this for the reference heading. See that? Every time I go back over to 330 thinking that's going to fix it, it doesn't. When we come down here, we'll get to 800 feet and we'll go missed. Needles, and remember, the needles get more sensitive the closer in you get. And once you get to 800 feet, or 814 feet, then it's a visual maneuver. If I broke out right now, I would add flaps and then just make a visual landing. But what we're gonna do, I'm gonna go carb heat off. Mixture is rich. We'll go mist. So the mist approach. Climb to 1,200 feet, and you gotta be careful that you don't pitch up too much. All right, airspeed's good. I'm gonna walk my flaps up. You don't be in a hurry to get rid of your flaps, and don't wait till you get some airspeed before you get rid of your flaps. So I'm gonna climb the runway heading, which is 330. We're gonna climb to 1,200 feet. And then once we do that, once we hit 1,200 feet, I'm going to make a right turn to a heading of 100. There's 1,200 feet. Right turn, 100. Continue to climb to 3,000. And you can see, I'm basically just trying to hold that dot right there. And that's going to keep everything right where I want it to be. Instead of trying to monitor 5 things at once, Just get it where you want it to be and just hold it there on your heading indicator. Or your attitude indicator, rather. And once we get to 100, we'll establish a straight ahead climb. There's that. And you should try flying these like this. It's a lot of fun and it's harder than you think it is. If you're not used to doing it. 100. Now we're going to switch back to the Utica, or to the Syracuse VOR 117.0. And we need a 018 on the OBS. I'm going to trim for the climb here. So we go 0. Ah, we're almost already there. Figure about right there. Alright, so that OBS is at about 018. Climbing 100 to 3,000 feet. And then we'll turn left. Outbound. And once we hit 15.9 right here, that means we are at that waypoint. Is there a power rate that translates to a descent rate, for example? Michael, so what the way you would do that, and the answer is yes. The way you would do that, and I've actually wanted to do a video on this for a while because it's fun stuff. You would go out in your airplane, go out in an area like this where there's nothing around, and just test your power settings and your attitudes. Like test your flap settings, your pitch settings, and your power settings. Like how can I climb at 90 knots at 500 feet a minute? What power do I need? What pitch attitude do I need? That sort of thing. Like for example, when I was doing my instrument training, I had to cut 50 RPM off all of my power settings when my instructor was in the plane. Interesting stuff, huh? So a small airplane like this, it's very, very weight dependent. But you would basically just go out in the airplane into what we call the practice area, which is like an area, it's like a designated area where there's just nothing going on. And you just test different pitch settings, different power settings, different flap settings. And flaps are up, carb heat's cold. And then you just write those numbers down. You basically memorize them. And then that will like, I mean, in my Cherokee, it was it 1800, 2 notches of flaps, 1850 RPM, and with the, so the way, the way you do it is like if your dot is right on the horizon, a dot above the horizon, dot below the horizon. And I think it was a dot below the horizon, 1850 RPM, 2 notches of flaps, was a 90 knot descent rate with, or 90 knot airspeed with 500 foot per minute descent in my Cherokee. So once you know that, you just fly those numbers basically. And the other thing is that you can, it's not going to fly exactly the same every day, and you may have quarter tanks of fuel, you may have 3/4 tanks of fuel, and that's gonna have an effect as well. Weight really has an effect on airplanes this size. So now I'm just waiting for that needle to start coming in. And we're at 13.3 DME. So we're kind of paralleling, we're perpendicular to this course. So we're pretty much maintaining that distance. See, now the needle's starting to come in. So now what you want to do is lead, depending on how fast it's coming in, you will lead the needle in the turn over to that 018. And then once we hit 15.9 and we're at pager, then I'm gonna do a teardrop entry. So I'm just gonna maintain this 100, 3,000 feet, And I'm gonna, right when it gets to the left side of this big, or the right side of this big circle is about when I'm gonna start making the turn. And that should get us pretty much spot on it. As you see, it's coming in pretty slowly because we're moving pretty slowly. Alright, so now, again, standard rate turn, get your little wingtip down on that white bar. And then keep an eye right here, what pitch do I need to hold to not be descending? And then just come around to 018 and release a little bit of back pressure there. Alright, and roll out 018. So, now we have that 018, the from flag, which means we're on the radial, which is perfect. This is not going to match up, by the way, the overhead at this point. And then once we hit 15.9 right here, once we hit 15.9, then we're at pager, and then I'm going to turn left to a heading of about 350. And that's going to be my teardrop entry into the hold. And wind doesn't seem to be doing anything to us right now, which is perfect. So weight and temperature, oh, absolutely. Weight and temperature would absolutely, temperature is the other thing. These airplanes are very sensitive to, the engines are very sensitive to temperature as well. Oh, there's 16.1. I totally missed it. I was daydreaming. one of the things, I'm going to turn to about 350, and then we're going to start our clock. There's about 350, and now we're going to fly 1 minute. And a clock with a hand is required equipment for IFR flight, and this is why. So now we are going this way, out this way. And you can see the needle is moving, and it's because the course is to our right. Now turn, time, twist, throttle, talk, so I gotta twist my thing into the 1198. So those are the 5 T's of, whoops. One thing you never want to hear your pilot say. 198. So turn, time, twist, throttle, talk. So there's a minute. So now I'm going to start a standard rate turn. Again, you get your little wing right on that, the little wingtip right in the white bar there. And just hold that attitude right there. My tendency is to pull back a little bit and gain some altitude, which is exactly what I'm doing. So I gotta let the nose drop a little bit. And then this needle will start coming in. I have a feeling this is gonna be pretty darn close. Be pretty darn close. Earlier I was having to make some pretty good corrections. And we'll roll out in 198, and look at that. Spot on. 3,000 feet, needle centered. I mean, that's about as good as it gets right there. So now we'll start counting 60 seconds. And we'll do one turn in the hold. And gladly, Michael, that's the whole idea today. I'm so glad you guys enjoy this stuff, because I could do this all day long. I love this sort of stuff. So what I want to do, so now I'm in the 198 heading, I want to see where this needle goes. Right? So if this needle starts to move to the right, then I know the wind is coming from the right. I'm getting pushed to the left. And I'm actually not even 198. I'm a I'm a little bit off there. Where did we start? About 10 seconds after the minute, rather. So, yep. So I think we're getting a little bit of a wind from about a little bit of a westerly wind, which is exactly what I would expect. So now we'll do our standard rate turn right there. And again, I'm climbing because that's my tendency. One of the things about flying, it's like anything else. You have tendencies of things that you tend to do. And I tend to gain altitude in turns. So we want an outbound heading of 018. And the timing on the inbound leg was actually pretty good. We'll check it again this time. And instrument flying, this type of stuff is boring, and it should be boring. There's 018, we'll hold that. And it's very procedural, it's very regimented, there's not a lot of creativity involved. It's like, you know, if you're into like aerobatics, this might not be your thing. This type of stuff, I love it. I absolutely love instrument flying. So much so that I didn't start my timer. I didn't see where I started the timer. I would say probably about maybe 20 seconds after. Let's see. There's so many things you got to think about. And the reason they put the clock right in the middle is because you need to know what your time is. So, let's call it about right there. Start our turn. And one of the tricks that my instrument, well, actually no, my first instructor taught me this one. So we want an inbound heading of 200, let's call it, right? If you get to a spot where the 200 is on this 45-degree tick mark right here, and the needle isn't moving yet. Oh, the needle's moving already. See, this is what was happening earlier. Then you would just hold your heading and wait. This is what was happening earlier. So there's a wind somewhere down here. So I'm going to come back through the heading here so we can correct back to the right. See how that needle's moving quite a bit over there. I'm going to go to about let's go to 210. And we'll hold it right there. See if we bring that needle back. Now about 40 after. 40 seconds after is where we start the clock. Now let's see how long it takes us to get to 15.9. And I'm gonna hold 215 because I think it's gonna be at least that much. Bring that needle back in. But this is the joy of flying holds, and I love this stuff. I think it's so much fun. Jeez, yeah, we're not going to even get... Let's see here. See, that needle's not even really coming back, and we're 15 degrees right of our course. Doing IFR training, does ATC make sure you have enough separation traffic? Absolutely. Well, it really depends. I mean, they will keep you separated from other IFR traffic, There's 40, by the way. So we are... How did we get so far out? 15.9. So we're gonna be 30 seconds off on this hold. So you are, when you're doing IFR training, you are technically, most of the time anyway, technically VFR. How far did I, so apparently when I missed my time earlier and didn't, because I wasn't paying attention, my guess was pretty far off. So once we hit 15.9, this was almost 2 minutes. This is gonna be 2 minutes. So, but they will, they know if you're flying approaches what you're doing and why you're doing it. But if you're legally VFR, is 15.9, they aren't going to separate you from, you have to have what's either what's called a safety pilot. So you've got, oh, I forgot to bring my foggles. I was going to show you guys my glasses, my foggles. But you would have another pilot sitting in the right seat, and they are the ones looking out for traffic. So let's goof around with this weather and see if we can get this approach in here. Where are we? Yeah, okay. Clear skies. Let's go overcast. Let's go rain. Yes. That's perfect. Okay. So now we're gonna finish this hold and then we'll go fly the approach again. So let's get 018. And if we make it, we make it. If we don't, we go missed. And then we'll call it a day after that. But okay, so about 50 seconds was the start of the outbound leg. So this is going to yeah, you wear the hood, that's correct. And I checked my altimeter. Oh, did the altimeter change? It is certainly getting a lot nastier up here, I'll tell you that. Alright, let's start our turn back in here. No. Don't you be doing that now. And what we'll do, we'll come down, we'll intercept at Osco. Or actually, I'm gonna self vector here. Gosh, the vertical speed is like all over the place. Alright. Trying to think and fly at the same time, that's not. Alright, get back in the game here. Yeah, so I'm gonna come through to about come through to about 215 and get that needle back in the middle, and then we'll go. Alright, now let me get that needle back centered. Okay. And then we'll just keep going southbound. I'm trying to think of how best to do this here. Three 330. I think what I'm gonna do, I'm going to come out here to the right a little bit, or to the left, or I mean, it's 15 miles to Syracuse VOR, so it gives us a little bit of time. So I think I'm going to come over this way. I'm heading over about 150 for a little bit. Once we cross this. Does not want to come down. I'm going to come out here a little bit, over in this area, and then turn right to the VOR, and then we'll just intercept from over there. Alright, there's 15.8. So here's what I'm going to do. Southbound, 100 and what? 150 degrees. Alright. So right now, we're heading basically this way. So this needle's going to keep going over to the right. But that's going to give us some room to be able to, it's going to give us some room to be able to come and intercept the, matter of fact, I'm going to go a little bit further to the left. About 170. And what I'll do, it is more difficult in the sim, Peter. There's no question about it. If you can do this stuff in the sim, you can do it in real life. Well, I shouldn't say that, but it's easier. It's easier to do in real life. If you know how to do it. Especially because in the sim, pressing buttons and turning knobs is not particularly easy. Which is one of the reasons why I like round gauge airplanes in the sim. Alright. So, let's see. Michael, I could, but the only thing about doing that is then I'm basically going the opposite direction of where I want to go. Like, then I would have to make a 180 degree turn kind of in a circle right here. So what I'm doing, I'm coming out this way a little bit, so then I can turn and come here basically perpendicular to this, rather than, just makes the turns easier. The one thing you don't want to do is have to make like really big turns on an approach. Like normally what they did on my let's see, what they did when I flew this on my instrument check ride, we were coming at about a heading of like 300. They give you about 30. They usually give you what they call like a 30-degree intercept. They'll give you a 300 heading, so you're coming this way, and then it's just a gentle 30-degree turn onto final, as opposed to a gentle nosedive into the ground, like I was just doing. So I'm just trying to get a little bit of spacing is all. Other thing I should do is turn on do I have pitot heat in this airplane? I don't think I do. I would certainly want it on if I did. Alright. So how far are we here? I'm basically paralleling this, so it's not. How far am I? Okay, 13.5. So I'm outside of. See, I just switched to the localizer frequency, and it's now 13.6. So I'm outside OSCO. So what I'm gonna do is, again, even though I don't have to, I'm gonna tune this to 330, and then what I'm gonna do is I'm gonna turn to a heading of about 300 to try and intercept. No, don't start climbing now. That's not what I need you to do. Even actually like 270. And with a constant speed propeller, your power is constantly changing too, so you gotta keep an eye on that. So basically right now we're heading westbound. We're over here somewhere heading westbound to intercept. The 330. And I know that the 330 is left of me because I've got this left indication. Remember, this is an ILS. So it's just showing me where the localizer course is, and the localizer course is to my left. It's over this way. Let's hope so anyway. .3. There we go. See, we're heading. Yeah, we're right at Hertgo. So what they would do now is if we were getting vectored like this, they would give us descend and maintain 2,400, turn right 30. Well, actually, we would hold this heading, but right now I am going to descend because otherwise we're going to hit Herty at 3,000. That's not going to be good. So I'm going to descend down to 2,400. I'm going to actually do that with flaps because I want to slow down and be nice and stable. I'm going to come down to 2,400. I'm actually going to come back a little left here. And then once I get to 2,400, then I'll just keep on keeping on until that localizer needle comes in. What I'd really like to see is the localizer to come in at the same time. Hey, Pharmatech, what's going on? Let's see here. So we'll go carb heat on, notch flaps. And you can imagine how much more challenging this used to be when you didn't have. I mean, you can even do this just on an iPad in the cockpit now, and it's completely legal. You have a chart with your little airplane on there. Makes it a lot easier to do. You know, whereas back in the day, you did it by paper, and you know, paper and instruments, and that's all you had. Alright, so I'm going to start leveling off at about 2,450. I'll just bring in a little bit of power and bring the nose up. Bring in maybe 100 RPM, bring the nose up. And... we go. I mean, it's going to be a 60-degree turn, which is more than I'd like, but that's all right. We're going so slow that it's not going to be a problem. Mixture is rich. Carpy is on notcha flaps. Then we're getting a little bit slow, so I'm going to bring in some power here. Why am I bringing in power if I'm getting slow? Because I'm in level flight. So if you're in level flight, adding power is gonna make you go faster. Come on, needle. So we'll be getting there. This is all gonna happen pretty quick here in a second. And we're at 8.6, so we're like 2.5 outside hurdle right now. Herty right now. And on a check ride, you have plus 100 minus 0. So you can go up to, right now I'm supposed to be at 2,400 feet. You can go up to 2,500 feet. You cannot go below 2,400 feet. Not by a foot. You will get failed. Alright. So we'll get that needle nicely. So you got to be pretty spot on with your altitudes. Alright, see, and again, earlier we were at about 320, 325, so I'm going to come back left. Oh, I changed the weather, that's right. Well, we'll see. We'll see, 325. That's coming in. We'll hold this right here. 7.3, so about 1.9 miles. Or 1.3 miles. We should be getting the glide slope. I'll let it come down just a little bit. So 325. Localizer needle's looking good. 6.6, we're right here, 6.5, so we're 0.6 from Herty. And this is what I want to see on a ILS. I want to be able to see this. I want to be able to see my minimums. So, oh, I'm goofing around, I didn't see it. Alright, we'll just bring some power out. Come back to the right here a little bit. And we'll catch up on both of those here. Alright. We'll go about 1900 RPM. Alright, 2200 for 814. And you just start counting down your altitudes. No, 814 is what I'm looking for. Is my minimum. So I just count it down. 2100 for 814. I just pulled out a little bit more power. 2000 for 819. I gotta come back to the left a little bit because that needle's starting to sway. So 325 is about what I want. I don't want to get any higher. Pulled out a little bit more power. 1800 for 814. I gotta get back here a little bit to the left. I'm gonna bring some power back in because I don't want to dive right through it. Alright, 320. 1900 RPM. 325. All right, 15 for 814. Okay, come back to 330. Uh, 1300 for 814. Power setting is perfect. Needle is still moving, so we'll go a little bit right here. 335. A little bit of power in. Okay, come back to 330. Now I just want to hold 330 and see if that's going to do it for me. I can't keep wiggling back and forth here. 11 for 814. Nope. See, there was that wind shift at 1,000 feet, and it's gotten me all goofed up now. 1,000 for 814. $900 for 814. Do I see it? Do I see it? Do I see it? I do not. Time to go. See, it's right there. See, this is the bugger of missed approaches. It's right there. As soon as I went missed, I saw it, but them's the brakes. Them's the brakes. Oh, that was a button. That's what happens, but you cannot go peeking trying to see what you find down there. That's how you kill yourself. So let's get the carpet off. The nose down just a little bit. Flaps up. There's 1,200 feet. Climbing right hand turn. Yeah, that's not a climbing turn, is it? That's a descending turn. And that's it. So we didn't make it. But, and that's the bastard of JGG, what's going on? Time to go. Time to go. So, yeah, I mean, we can try again if you guys want to. I don't know how much time everybody's got. Flying ILS into Lima. For those of you who don't know, JGG pilot is an American Airlines Airbus pilot. So when he says he's flying an approach into Lima, he's flying an approach into Lima. That's awesome. Oh, nice, dude. I'll check that out. So, let me see. Let me see. I reset it to... Alright, hold on. Maybe that's why. Maybe that's why. I hit B. I could have sworn. But if you guys want me to take one more shot at it, I'll take another crack at it, but... We can, I mean, I could go... Oh, no. That right there is carbise, I betcha. Alright, carbise. Alright, this is gonna be a fun one. This is gonna be with a tailwind too in this direction, which is exactly what I need. Did I just run out of fuel? I just ran out of fuel. Okay, so things not to do. That's hilarious. I just ran out of fuel. Alright. I got the field made easily. So I'm gonna make a little bit of a right turn here. Well, I had the field made easily until I added flaps. Tell me I just put myself in the trees. Alright, we're going straight in. Just this is gonna be the greatest end to a stream ever. Alright, second notch of flaps. And all I'm trying to do right now is get it on level ground. The airplane belongs to the insurance company. That's it. That's it. Oh man, that's hysterical. So, in case you're wondering what just happened, I just ran out of gas. But look at that, ladies and gentlemen. Just hitch a ride here and get home. So yeah, I mean I lucked out where that happened. Boy, oh boy, oh boy. Look at the power lines. How cool is that? So, yeah, 7,700 out of nowhere, exactly. Hey Michael, thanks for coming out, man. I appreciate it. And yeah, so that was a nice lesson in what not to do. So I mean, I never even looked when I loaded the plane, but I wasn't planning on flying for as long as I did. But anyway, yeah, I mean, that was actually pretty well handled, I have to say. The only thing I would have done differently, I should have done differently, is it looked like I was landing into a bit of an upslope there, and I definitely didn't want to like clunk it right into the side of a hill, even a little hill. But I mean, a field like this with nice crop in it is perfect. You know, it's perfect. So hey, we lived, and now I know what to do next time. Guys, thank you so much for coming out. I really appreciate everybody's patience. I hope you guys learned something. I certainly did. Look at your fuel tanks every once in a while. Yeah, I really appreciate it, everybody. And we'll do this again on Thursday. I'm gonna find another approach. We'll do it again Thursday at about 1 o'clock, same time. So thanks everybody for coming out. JGG, I've been meaning to get in touch. I will reach out, man. But everybody else, thank you so much, guys, for coming out and watching. I really appreciate it. Appreciate the support. If you're so inclined, I have you can join the channel. There's a link. There's a button down below that says join, or in the description there is a link to my Patreon if you want to help me with my endeavors. And I just really appreciate everybody's time. So thanks everybody for coming out, and I'll see you guys again on Thursday. Take care, everybody.